we have learned two important relation with the introduction part. What is these two? One is the relationship between electric field and potential difference. That is E is equal to minus dV by dr. And next one is the definition for potential difference. What is that? VAB is nothing but WAB divided by Q, which is nothing but work done in bringing a charge of Q from B to A divided by the value of Q will be giving us the value of potential difference in between A and B. This is very important. Okay, when you know the potential difference in between 2 points, let's say you know point 1 and point 2. The potential difference in between that is, let's say, 50 volt. Now, what is volt? Volt is nothing but the units used for measuring potential difference, V. So, 50 volt is the potential difference in between 1 and 2. Let's say V1 minus V2, that is in between 1 and 2. Now, how much energy should I spend in bringing 1 coulomb, or let's say 4 coulomb from 2 to 1, or how much work should I do in bringing a charge of 4 coulomb from 2 to 1? See, you can use this equation. You can also use this equation to find work done. What is the work done? WAB from these two, WAB is equal to VAB into Q. So simply we have to multiply the potential difference, which is 50, with the charge 4, we will get the work done. Clear? Work done or change in energy. So to move a charge from charge of 4 coulomb from 2 to 1, where the potential difference in between 1 and 2, here in this case V1 minus V2 is 50, is nothing but 50 into, that is the potential difference. So VAB, here in this case V12 into the charge Q. So here in this case V12 is nothing but 50 volt. 50 into charge is 4 coulombs, which is, so this is volt and this is coulomb. So what will be the value? 50 into 40, 200. What is the unit of work done? Joules. Clear? I can also define what is 1 volt. So here keep the value of VAB as 1. So 1 is equal to, I am going to keep it as 1 is equal to 1 by 1. So VAB is equal to 1, WAB is equal to 1, Q is equal to 1. This equation will be correct, right? VAB is 1, WAB is 1, Q is 1. So this can be defined in a different way. What is that? See, when VAB is 1, WAB is equal to 1, Q is equal to 1. In this scenario, it means that whenever I am taking a charge of 1 coulomb in between 2 points having a potential difference of 1 volt, the total work done is nothing but, what is that? Potential difference into charge, 1 into 1, which is 1 joule. See, what is 1 joule? 1 joule is the work done or change in energy. So here in this case, change in energy will be nothing but work done. That is nothing but energy conservation, right? So work done or change in energy in, moving a charge from a position to another position having a potential difference of 1 volt. So work done in moving a charge of 1 coulomb through a potential difference of 1 volt is nothing but 1 joule. So that with that relation we can define what is 1 joule, what is 1 volt, even 1 coulomb we can define. Anyway, come back to this. Here we will learn what is the dimension and unit of E and V. So we know we will use this equation because we are very familiar with the dimensions and units of work and coulomb. So coulomb, how can we get the dimension of coulomb? We know what is current. Current is equal to Q by T. So dimension of current is ampere. Dimension of time is T itself. So Q is equal to dimension of Q is equal to dimension of I into dimension of T. So dimension of I is ampere A. Dimension of T is AT. I mean dimension of T itself. So dimension of Q is AT. Now with this equation, dimension for potential difference is equal to dimension of work done divided by dimension of Q. Dimension of Q we already found out 80, and work done we already know ml square T power minus 2, and divided by dimension of Q, which is nothing but 80. So this will become m L square A power minus 1 T power minus 3. This is the dimension of what? Dimension of volt. Make a note of it. And next thing is, what is the unit of E? We can easily get the unit of E with this relation. Unit of E is nothing but from here unit of V divided by unit of dr. What is unit of V? We know volt. And what is unit of dr? Dr is nothing but displacement, which is meter. So we can simply say this is a new value or new unit for electric field. Electric field is nothing but volt divided by meter or volt per meter. So this is very important and this is very important, and also you will be asked to find the work done when you are moving a charge of Q in between a potential difference of V value. Clear? Thank you.